Okay, let's jump right into this explainer. Today, we're going to demystify the absolute mind-bending complexity of modern production systems. If you've ever built a simple web app, you totally know that thrill of finally getting it to run locally. But right now, we are completely shifting our mindset. We're moving from just writing code to running software reliably at scale. Because honestly, the truth is, the tech stacks powering the apps we use every single day, they look absolutely nothing like the tutorials we all started with.
To actually make sense of this massive modern architecture, we're going to build our knowledge floor by floor. We'll hit 5 crucial phases: the beginner stack illusion, scaling for speed, building for true reliability, keeping the system alive, and finally, deploying like a pro.
All right, let's kick things off with Phase 1, the beginner stack illusion, breaking down the whole tutorial myth.
If you've taken a bootcamp, you definitely know this beautifully simple 3-step dream setup. Step 1, front-end sends a request. Step 2, backend gets it. Step 3, it talks directly to the database and sends data right back to the user. It's clean, it's super easy to wrap your head around, and hey, it works perfectly. As long as you only have about 10 users and absolutely nothing ever breaks. But jump into a real production environment, and boom, that beginner illusion completely shatters. To handle actual, real-world traffic securely, companies aren't using 3 little steps. They're using a massive, interconnected architecture of often 15 or more moving parts. We're talking API gateways to route the traffic, Redis for speed, queues for the heavy lifting, and this entire ecosystem of monitoring tools just to keep the lights on. It's a whole different ballgame.
Take authentication, for example. It isn't just a simple wooden door you can slap a padlock on. It requires a literal steel vault. In a real company, Auth is this deeply robust system. You need access tokens, refresh tokens, role-based access control. Just think about it. A regular user can view a product, right? But an admin needs to actually manage products, and the finance team needs to see payments. So you need strict session expiry, device tracking, and full audit logs just to remain totally secure and compliant.
And moving beyond just the code itself, real systems strictly separate their environments. You've got local development, staging, and production. What this really means is you can never ever safely hard-code API keys or payment credentials directly into your application code. I mean, we've all heard those absolute nightmare stories of an AWS key getting pushed to GitHub, right? And suddenly you're waking up to a $50,000 server bill. Real companies use dedicated secret managers and environment variables so that a leaked source code file doesn't instantly trigger a massive data breach. Moving right along to Section 2, scaling for speed, moving beyond basic tables. Let's see what happens when user traffic suddenly spikes from 100 users to 100,000. Because look, a beautifully clean backend literally means nothing if your database is dragging along at a snail's pace. Junior developers tend to just think in terms of basic tables, but real companies, they strap rockets to their databases through obsessive design. They rely on indexes to massively speed up searches, transactions to ensure absolute data integrity, and really strict migration so they can alter structures safely without accidentally dropping critical user data. Basically, bad database design will bottleneck your entire system, no matter how fast your servers actually are.
And this is exactly why real production-level systems never store files or images directly in the database. Shoving user avatars or big PDF documents in the database rows just causes massive bloat and slows the whole thing to a crawl. Instead, the pros rely on clean, infinitely scalable object storage. Think Amazon S3 or Cloudflare R2. The database? It only holds the lightweight metadata, like the actual URL to find the file.
Now, to protect that primary database even more, enterprise stacks bring in Redis. Redis is this incredibly fast, in-memory data store. Instead of asking your main database to calculate the exact same popular query 1,000 times every single second, you just cache that frequently read data right in Redis. It's also amazing for rate-limiting users and storing temporary session tokens. It dramatically improves response times for the end user, and honestly, it saves your main database from a total meltdown.
All right, part 3, building for true reliability, handling those inevitable failures. Because out there on the wild west of the internet, things break literally all the time.
Let me paint a picture for you. A user clicks sign up, and your system immediately needs to send them a welcome email or verification text. But what happens if that third-party email provider goes completely offline? Does your user's app just freeze on a spinning loading wheel forever?
You absolutely do not want that. To prevent a failure from freezing the user's screen, we decouple the work using a queue system. The API receives the user's request, drops a message into the queue, and immediately answers the user saying, "Success." Meanwhile, a dedicated background worker silently picks up that heavy task from the queue,
like actually sending the email or processing their credit card, and handles it totally behind the scenes without blocking the main app. Okay, but what if the worker tries to send that email and the external provider is still down? Well, a bad system just fails and totally forgets the task. A professional retry system steps in here. It uses a specific retry count and something called exponential backoff, which is just a fancy way of saying it waits 1 second, then maybe 5 seconds, then 30 seconds before trying again. If it completely fails after all that, it drops the task into a dead letter queue so an actual human engineer can review it later. That kind of resilience, that's one of the biggest differences between a weekend toy app and a true production system.
Okay, phase 4, keeping the system alive, seeing inside your app. Because once you've got dozens of background workers, API gateways, and databases all running at the same time, you are flying completely blind without a way to look under the hood.
Your basic monitoring might tell you, hey, CPU usage is spiking. But when you are bleary-eyed at 3 a.m. trying to fix a massive production crash, a bad log that just says error is totally useless. A good, structured log gives you the exact timestamp, the specific user ID, the error trace, and a unique request ID. It literally allows you to retrace the exact journey of the specific user who experienced the failure.
So we're talking about a profound shift here, moving from standard monitoring to true observability. Monitoring tells you that a checkout request is slow, right? Observability uses a mix of logs, metrics, and distributed traces to show you exactly why. It can pinpoint the exact database query buried deep down inside your microservices that caused the bottleneck. It completely eliminates the need for your engineering team to just sit there and guess.
But hey, all that incredible visibility, totally useless if nobody's actually awake to look at the dashboards. That is exactly why robust alerting is absolutely required. Think about it. If your queue jobs get stuck but the main API is still responding, your users might not notice right away, but your business is technically broken in the background. Automated alerts routed straight to Slack or PagerDuty wake the right engineers up, fixing that silent business failure before customers even have a chance to get onto Twitter and complain.
Finally, Section 5, Deploying like a Pro, focusing on consistency and automation. Let's look at how teams actually manage to safely push updates to this massive, interconnected beast of an architecture without breaking everything.
So, manually deploying software? That is a total recipe for disaster. Tools like Docker absolutely eliminate the classic, infamous, well, it works on my machine excuse. Docker takes the app, the exact specific version of the database, the Redis cache, the workers, and wraps them all up into perfectly consistent, isolated containers. This completely guarantees that whatever runs perfectly on a developer's laptop is going to behave the exact same way out on the live production servers.
And when you pair those Docker containers with CI/CD, continuous integration and continuous deployment pipelines, teams completely automate their workflow. The minute new code is pushed, the system automatically builds it, runs a battery of automated tests, and safely deploys it to the servers. It permanently eliminates manual server mistakes. It basically stops developers from ever accidentally pushing broken code to the live environment.
So, when looking at all of this, a junior developer usually stops at one single, simple question. Does it work? They write the code, they test the happy path, and if they can successfully log in, they dust off their hands and consider the job done.
But the true mark of a senior developer and a real professional tech company is constantly asking, what happens when it fails? Real companies don't just want code that works perfectly on a sunny day. They demand systems that are highly secure, totally observable, incredibly scalable, and instantly recoverable for the exact moment everything hits the fan. So I want to leave you with this thought to ponder today. Next time you sit down to write a new feature, ask yourself, are you just making it work, or are you actually engineering it to survive?